Hello, everybody, and welcome to this week's episode of Adventures in .NET. My name is Adam Frumanek, and today it's Christian Wenz with me, and
Hi,
we are
Adam.
going to have a panelist discussion just for the two of us. So, welcome again. And Christian brought today an article and a very interesting topic. So, Christian, would you give us some understanding what you brought and why you find it very nice to discuss?
Oh, absolutely. Thanks, Adam. So, as probably many of you know, security or web security is one of my main topics. I once was a guest on that very topic, actually, with regards to ASP.NET Core on this show. And the one of the most well-known, let's say, awareness documents for web application security is the OWASP Top 10. Right? It's a list of the 10 top security risks for web applications, curated by the Open Web Application Security Project, OWASP, homepage owasp.org, which is a non-for-profit organization or registers as such. Has a wealth of information, lots of documentation. How do I prevent attack X with stack Y? Cheat sheets, verification standards, also software, dynamic web application scanner, which can find some security vulnerabilities, web applications that have intentional security vulnerabilities, so they can be used to train some pen testing and much more. And yeah, also a couple of top 10 lists actually, and the best known one is the OWASP Top 10. I think it started in 2003, and the OWASP itself started in 2001. And then at the beginning, they had a new top 10 list every year. But assembling that list and have it kind of predictable and make it data-based was quite an effort. So what they actually did was that they then went to a 3-year cadence. They did not make that the last 2 times. So we know at a 4-year cadence, and the most recent version of that list is the 2021 OWASP Top 10. But before you switch to another show, hear me out. That list, I mean, super important, right? But there are other top 10 lists as well, and they are not as famous, right? They're a little bit underneath the radar. So, for instance, there's one top 10 related to Docker, for instance, right? All super interesting, and of course, with all of those lists. So maybe let me put that first. With all of those lists, they are awareness lists, right? If there are 10 items on the list and you have a limited amount of time, you can't just say, okay, I do 1 through 7, right? Because they are just much more important. Based on the data, and of course on the bias of those delivering the data, and maybe also the bias of those compiling the list. Yeah, to them, 1 through 7 might be the most important ones, but for you or for your applications or for your stack or for the way you are doing web software, it might be entirely different, right? So it's an awareness document. It's not a list of top 10 attacks, it's a list of risks. And some of them come directly from attacks, some of them are more conceptual. For instance, in that current OWASP Top 10, one item is insecure design. Right? Which, I mean, yeah, it's a risk. I get that. It's not so actionable as some of the others, which are more tied to specific attacks. But anyway, right? So it's an awareness document. So take everything with a grain of salt. And as I
That
mentioned,
sounds really, really cool. One question I'd
yeah,
like to ask here initially, like you mentioned, all those lists and the
yeah.
tooling, and they are very old. But the one thing which I always find interesting is how can I actually apply that list
Yeah.
directly in the code? Are there any ways?
It's not like a how to fix your application list, because I mean the problem, maybe if you take a 10,000 feet view, right? The problem with security is you don't see an absence of it, right? It's like brushing your teeth, right? So while we're recording this, we are seeing each other, but we're not in the same room, right? And I mean, I have no idea whether you are brushing your teeth today, right? And vice versa. I have a hunch, but so
Very
we
good
just don't
metaphor.
see it. But um, the absence of security or the absence of brushing your teeth is not obvious unless it's too late, right? So I leave it up to your imagination what happens if you don't brush your teeth for a year. But if there is no security in a web application, one way to find that out is if someone hacks it. And so that's a little bit of the problem. So, and that's why awareness is key, right? You have to protect against things that are not there yet, right? And maybe even against kinds of attacks that have not really been invented yet. So you always have to have a very defensive approach to the way you build your software, and that awareness list kind of makes you aware of risks that can happen. Now, with that given, still for each entry in the say OWASP top 10, for instance, there are more or less precise examples of typical occurrences of that risk or typical aspects. How could this risk kind of materialize in your applications? And of course, then you might have countermeasures against it, right? So yeah, that is the case, at least for some of the aspects. But usually, I mean, no, I have to rephrase that. What I often find is that security is reactive, right? So you do something because someone found something, but it would be much better, of course, if you are in the driver's seat, right? And you start putting security in your applications, right? From
So
the very, very start. Yeah.
that sounds like an never-ending story, right?
Of
It's
course.
not that you check it out once when starting your
Yeah.
project. You need to refresh that periodically because the world changes, right?
Absolutely, absolutely. I mean, there are
Gotcha.
companies I visit every year or every 2 years, right? And then they still want awareness, 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 awareness. People, leave, new people come in, and I mean, not everyone is kind of responsible as in having the title of being whatever security engineer, but every engineer has to know enough about security to write solid and secure code and
That
maybe
sounds cool.
supported by a security engineer.
That sounds cool. So before actually diving
Yeah,
into the list you brought
yeah,
for us today,
yeah,
like one practical question, I imagine. Obviously, we know there is like secure software supply chain, there
yeah.
is cybersecurity, obviously infosec in big corps and
Hmm.
whatnot. But what is like the practical approach for like let's say software engineers that really do the coding?
Yeah.
Still, they would like to keep their applications safe and secure. How can they tackle this problem on some like regular cadence so their applications do not rot, do not go insecure because of whatever?
I think there are several ingredients, right? And depending on the size of the company or of the team, then more can be done or less can be done. So one aspect, of course, is just training awareness, right? I mean, the risks for web applications they are all the same, no matter what kind of stack you're using. Although, for instance, since we're here at Adventures in .NET, ASP.NET Core has some pretty solid protections against some attacks. Still, that's not no excuse for not knowing about them, right? So you have to have that awareness. But still, the stack protects you, but the risks are the same. The countermeasures are specific. So being aware of the risks, knowing about specific technology-specific countermeasures is, of course, important. If you have someone responsible for security, like a security engineer that, I don't know, takes part in code reviews, takes part in design reviews, is always helpful. And of course, also testing your applications either internally or externally on a regular basis. This all can help. And I mean, if you're a small team, then and have a software that is that doesn't generate millions of dollars, right? Then maybe you are less inclined to pay for a pen test. And if you do, then maybe you are. So, but again, it really depends on the scenario. But I think these are kind of ingredients: awareness, training, knowing how to write secure code, and having someone on the team who wears the security hat and makes sure that security is part of the process, right? And not an afterthought, right? Like a patch you put on a flash wound or something.
That sounds really good and I like it. Okay, so I imagine
Right.
you brought a list with you for
In
today's episode.
indeed. So as I mentioned, there are other top 10 lists, and there has been one that was released in 2019, if I'm not mistaken. But in May 2023, so not that long ago, they released a new version, the 2023 version, and it's the OWASP API Security Top 10. So it's not the OWASP Top 10, which is general for web applications. It's the API Security Top 10. There is the OWASP API Security Project, and that project tries to curate a top 10 list specifically for APIs. And I mean, more and more applications these days, right? They have this typical pattern, the single page application, where basically you have static assets in the browser, and then the functionality and the data, etc. That all goes through an API. And I mean, an API is like a web application, right? So usually you talk to it via HTTP, something similar. If you can open the API results directly in a browser, you might be careful with regards to JavaScript being injected, just to give one example, right? Although that's rare. And then, of course, on the server, you may have a database, so you have to look out for stuff there. So it's similar to web applications, but still it's different because some type of attacks or risks are more common in APIs than regular web applications and vice versa. For instance, the JavaScript injection, or a more precise cross-site scripting. Cross-site scripting is typical for web applications, right? It's rather rare for APIs because usually with APIs, what you do is you get data, you process data, and then when you return data, in most technology stacks, you basically say, okay, this is the object, this is the data, this is the array, this is the whatever that I'd like the API to return. Here, technology stack, or here, framework of choice. Please put that into JSON. I don't really care. And then that framework returns properly formatted JSON with the correct content type, so that the browser does not render that as HTML, and therefore no JavaScript is part of that. So cross-site scripting is rare. That doesn't mean it cannot happen, but it is rare, right? And so that's why those lists are different. And I mean, more and more applications, at least the ones I'm seeing, and maybe it's similar for you, they are using APIs a lot. And even if you don't have a single page application, still lots of software is just using APIs.
Yeah, I think API generally the concept is nothing like, to this essence, is not related to web security, web APIs, or web applications in general, right? APIs are with us for many decades, and generally, even though today we think about the web world, it's not always the case. And cross-site scripting, as you mentioned, that's like JavaScript injection is basically about browsers, right? But when you are doing like, I don't know, backend and some embedded software or whatever, then you also use APIs and, for instance, scripts like Lua scripts and other stuff. I imagine cross-site scripting, maybe not the definitional cross-site scripting as we have with web browser, could also happen in these scenarios. What do you think?
It could, but it's very, very rare because of the built-in stack protection. And just to give you a spoiler, so there is no cross-site scripting entry in the API top 10. And I agree here. Let me put it that way. Why? Or maybe if I say, okay, do I agree with that list? I mean, how kind of biased is that? Because the latest OWASP top 10 minus API was very, very data driven. So practitioners, people who, companies who do pen tests, etc., they kind of provided their results of their pen tests. So what was found, how often, and then this was kind of categorized and put into buckets so that we get a couple of categories. And again, it was very data driven. I mean, there were some babe factors which were added, so the exploitability, for instance, and other stuff. So that could add some bias. Also, the grouping is some bias, if you'd like to call it that way. But I mean, still, they tried to make it as data driven as possible. The API project tried the same. So they started with different databases, like public reports about security issues in APIs. I think they were using some bug bounty platforms, and then some public CVEs. And then they also did a data call. So please give us data, but they didn't get enough, right? So basically they discarded the data and were sticking with what they got. And then again, categorized it, talked to people, massaged the data. So, and I mean, massaging data always sounds like cheating, but I mean, it still has to be kind of coherent and kind of make sense. And maybe it should also match with expectations from practitioners in the field. So I mean, that's good enough for me because it's an awareness list, right? Because I say I don't care if something is number 3 or number 4. If it's there, I have to be aware of that, right?
That sounds really cool.
Yeah.
Okay, so we know how it all started. We kind of know how it goes. So how about we go and see the list, what it brings for us this year?
Absolutely. So let's go through the list or through all 10 items. And I think many of them we can cover briefly, but some of them maybe we can discuss in more depth. So let's just have a holistic look at it. And um, may I once again quickly peek at the big, so to speak, OWASP top 10, because they are the current number 1 entry in the current 2021 edition is called broken access control, which we understand that, right? It's a risk, yada yada. And in previous versions of the OWASP top 10, that was split up into access to what was broken, right? Because it makes a difference if you access data or if you access functionality or if you access something else and you don't have proper, say, authentication or authorization there, right? The OWASP top 10 can do that, so they could put everything into this one broken access control bucket because there were enough other buckets to fill. For APIs, maybe not so much, and that's why they split this up. And therefore, the number 1 entry in the 2023 API security top 10 is broken object level authorization, right?
That's magical. Can you clarify a little bit? What's that about?
We try to access an object, so often that's data, and we have broken authorization. So the authorization there does not work. I mean, there are simple examples, right? So that there is a data.json file publicly available on a server, right? Which is directly accessible. And I mean, that sounds dumb, right? Maybe it is dumb, to be honest. But it kind of categorizes that risk really, really well. So we can get access to objects, essentially to data, without proper authorization. I mean, we are one of those typical examples from web applications, right? So you log into an application and then you have a URL like, well, now it's an API. So we would have an API endpoint like whatever slash I don't know
Invoice.
invoices slash 123, right? And since you're authenticated, why not use 124, right? If you get
Exactly.
data as well, and that's not your invoice, that's basically in that bucket, right? And
So I imagine everything that may fall into these categories, for
yeah,
instance, any mechanism that lets me iterate over objects by guessing their identifiers,
that
which
would
I
work as well.
shouldn't be able to access,
Yeah,
right?
exactly.
Yeah. And any like practical considerations for that? Like, should I don't know, randomize identifiers, use global UIDs or
Yeah,
whatever, or
I
just change the, mechanism to not let anyone read those files?
I think I mean I'm a fan of having GUIDs as identifiers, indeed, but I know, how practical and easy and digestible it is if we have integers, what a lot of people are doing. I mean, it's not a problem. Oh, well, it's not necessarily a problem if someone guesses an invoice, as long as we do authorization. Does this user have the privileges to access that specific invoice, right? So I think that's the idea, right?
Yeah. One thing I would add to this, I am not
Mm-hmm.
an expert in OWASP, so I
Yeah,
don't know whether it actually falls into this category, but like pre-signed URLs,
yeah.
that is something that like we programmers, we know that we are lazy. And when we generate a pre-signed URL, when should it
Mm-hmm.
expire?
Yeah,
Ideally
yeah,
never, because it's convenient, right?
yeah, yeah,
But
yeah,
that's
yeah.
the very easy way to actually break this mechanism, right? You get
Absolutely.
an object, you pre-sign URL, and bang, you publicize it anywhere. And
Yeah.
one of the issues, the practical issue, and this is something I actually faced in like my career,
Mm-hmm.
was maybe a little bit different, but still on the same idea, like single sign-on URL.
Yeah.
When you confirm user account or
Mm-hmm.
whatever,
Mm-hmm.
when you send those links over email to your users, our beloved email clients, they tend to basically take the thumbnail of the
Yeah,
URL, take the
yeah,
snapshot,
yeah,
and
yeah,
bang,
yeah, yeah,
kill our URLs this way.
yeah. Exactly. And I mean, also one of those typical rules is right. If you have an HTTP method get, it should not change the state of the application, right?
Yeah,
But yeah, in that
exactly.
case, it does. Yeah. I mean, it's really bad, right? Also, especially some web-based mail providers, they try to check the links in emails to find out whether they are malicious or whether they point to something that is considered dangerous. So they're also trying to load that URL, right?
Cool. Okay.
Ah, bummer,
Shall we
bummer.
move on?
Yeah, indeed. Number two, super generic, broken authentication. And I mean, broken authentication can be anything, right? So you have an API that has guest/guest as credentials, or you have an API that is using JSON Web Tokens, uh, but accepts JWTs that are not signed, right? Or you have an application where the JWT doesn't have an expiration date, or the expiration date is not checked, stuff like that, right? And I mean, that's number two. I was a bit surprised to see that because quite often, especially when you have an API, you don't really manually do the authentication, right? You use what your framework is providing you with. So, for instance, with ASP.NET Core, you really have to explicit disable the signing requirement, for instance, for JWTs. But if I'm not mistaken, actually that specific thing doesn't even have an effect. So you have to have signed JWTs anyway, right? So you can
Yeah.
kind of override the mechanism that validates this, but you can't just say, well, you could say, but it kind of doesn't work. It doesn't change the behavior. You can't say, yeah, don't check the signature. No, if there's a signature, it will be checked. Right?
I think there are two, if I was a
Mm,
programmer
yeah,
thinking about this rule, I think there would be two places where I could get it wrong. First one is obviously for my local or dev environment, I'm gonna cut corners like crazy, disable that stuff, and then I just forget to re-enable it in production for whatever reason. But second thing, and this is again something I like encountered in the companies, is breaking this mechanism
yeah,
by using seemingly secure things incorrectly. For instance, having like a physical YubiKey to make the authentication work well with multi-factor, but not using this hashing option of YubiKey, but instead generating one-time key. And because YubiKey doesn't have the clock in it,
yeah,
then if I regenerate it accidentally, it never expires. Which is cool, can also be considered a feature for some use
yes,
cases.
it is a feature indeed. All
Yeah,
right, good.
cool.
Let's pivot to number three, broken object property level authorization. That sounds a bit complicated. And I mean, what's the difference between broken object level authorization and broken object property level authorization? I think a typical example would be what is maybe related to mass assignment or overposting for regular quote unquote web applications. So imagine you have an endpoint, whatever, API endpoint create user, right? And you can send the user with a username and an email address and maybe the password, right? But the model on the server also has other properties for the users. For instance, the property, and I mean, I make this, as boilerplate as possible, right? So you wouldn't do this in practice, right? But just to get the idea across. So let's just imagine the user had a Boolean property. You know where I'm going at, right? A Boolean property is admin, right? So what if that create user request gets not only username and credentials and email address and whatever, but also is admin : true? Because especially if you do something like model binding, which of course is very popular with ASP.NET Core and thus ASP.NET Core Web API as well, then if is admin is a public property of that model, it would be bound as well. And that would mean we would have broken object property level authorization, right?
And this is actually a very common case. At
It
least I've
is.
seen that in experience, like in practice, many times. Especially when we reuse the same model for like database
Yeah,
storage and view models on the API side.
yeah, exactly. Yeah. So
Yeah.
view
And
models
then we use
appears. Yeah,
automapper or whatever,
yeah,
which does the magic with
yeah.
bindings, and there we
Exactly,
go.
exactly. Yeah. So use a view model, or I mean, if you don't, if you just use what ASP.NET Core gives you, you have the include and exclude attributes. So you can have an allow list or a deny list for properties which may be bound and which may not be bound.
Yeah,
Right?
and this is especially tricky because one of the other so-called quote unquote best practice
Mm,
is whenever you have an API and you do
mhm.
not recognize some properties, just let them pass through for
Yeah,
compatibility, right? Backwards and forwards. And this way you can break this what it was called broken object property
yeah,
level
yeah.
authorization, right?
Exactly, exactly. All right.
Cool, cool.
Number four, and that's something, I mean, that could happen or is a risk for web application as well. But for APIs, I think it's more relevant. It's unrestricted resource consumption, right? So that the API is subject to a denial of service attack. Or what I see more and more often is lots of applications these days, they're using GraphQL. But I mean, GraphQL is kind of complex, and with complexity, of course, always comes the risk that there is some abuse possible. And one thing I recently found in an audit, for instance, was there was a GraphQL query where um, some really complex database logic was triggered by a GraphQL call, and the application therefore was using paging for the results and was setting a page size as part of the GraphQL query. So we could find out that you could change that query and use a very large page size, and that would basically issue a denial of service attack against the application, right? So you have to have some kind of rate limiting. You have to have some monitoring, and again, that depends on the app. Maybe some auto scaling where it's hosted, or just some threshold. Okay, this much traffic, this much resource allocation, this size of the incoming HTTP request, payload, etc. This is the limit, and deny everything else.
Two things come to my mind when you mention this. First is actually what happened with Twitter, at least what they claim happened, that they like were abused heavily
Yeah,
for text messages, right?
yeah,
So everyone was just using Twitter just to make them send second factor
yeah,
and pay for it and
yeah,
then
yeah, yeah,
wasting it, right? And second thing that comes to my mind is any kind of reflection attacks, I think, like some services, for instance, DNS. Or Active Directory, they let you basically, when they can't handle some request, they route it to some other server,
yeah,
right? And if you control that, then basically you can incur additional charges or even DDoS,
yeah,
some other services this way.
absolutely. All right, ready for yet another broken authorization
Let's
thing?
go for
It's the
it.
last one. It's number 5 on the list. It's broken. I mean, we have had objects, we have had object properties. So now we're missing the functionality aspect. So broken function level authorization. So basically,
Okay.
we don't access data, we access a functionality. And with APIs, I mean, if it's a GET request, it's usually data. If it's something like POST, often it's the functionality that we are calling. So basically, it's the same thing, but this time we are accessing some functionality, or a function, as they call it in that list, right? And
So basically, it's calling an endpoint,
yeah,
then I should be able to call,
yeah.
right?
I mean, web applications have these two generic rules: validate input and escape output, right? Of course, you cannot validate each and every input. Think of free text fields, right? But then if you process the data, then you have to escape it before you stuff it into SQL or put it in HTML, right? To avoid SQL injection or cross-site scripting. And for many API calls, I mean, still validate validate the incoming request, whether you get the data you expect or too much or too little or the right properties, but they have too much data in them. Whatever you can validate, just do.
Just do.
Yeah.
That sounds like a very good rule of thumb.
It's
Let's carry on then.
yeah, indeed. Let's quickly move over to number 6. Unrestricted access to sensitive business flows.
And now this gets serious because we mentioned business finally,
Yes.
right?
So finally, it's getting expensive. Exactly. I mean, indeed, with every API endpoint we are calling in a business application, it somehow pays into the process that is happening, right? And those let's say those endpoints or those API parts that are close to the revenue of a company, they should be vetted extra hard, right? So I think an example the OWASP is giving is if you automate referral systems of a company, right? So that you get a referral bonus if you refer someone else, and if you kind of automate this, and therefore make sure you always get a referral bonus when providing whatever a new customer, or I think are they using ride sharing as an example? I don't remember actually, but I think it's ride sharing, right? So whenever you bring a customer for a ride, that you could hypothetically automate that process of setting up for referral and then getting the referral bonus, right? So and I mean the differences between those items we've had so far, they are relatively subtle, right? But as you rightfully pointed out, if I just say validate the data as good as you can, that is factually correct, right? And it's probably solid advice, but it's not tangible. But think about the data you can access. Think about any properties request could set. Think about the functionality that can be called. Think about which of the APIs trigger which business processes. I think this awareness, and there we are again, awareness, this awareness I think is key.
Especially that when I read the description of this rule, right,
Yeah.
which is if used excessively in an automated manner, then it
Yeah.
harms the business.
Yeah.
And one thing that came to my mind is what if like we make a human mistake and when we post an item for selling on the page, we like miss number of zeros, right? And we start selling something 10 times cheaper than we should. And when someone makes an order for like not buying one piece of that item, but 1,000 pieces of that, should we allow for that or not? How should we cover that? And how would we even notice that this happened, right? Do we have monitoring for cases like
exactly. The OWASP top 10 number 9 item, by the way, is insufficient logging and monitoring.
We'll get to that. First, let's move on to
no, we
numbers.
won't, because that was the OWASP top 10. The API top 10 does not have
that is exactly right.
That item, right? So, but again, so you see the focus is a bit different, but I think all of this is of course of equal importance. I'm a bit torn. I have to be honest. I am a bit torn about number 7. It's server-side request forgery. Server-side request forgery. That's not cross-site request forgery. That's something else. That's cross-site request forgery basically abuses the way cookies work, at least in the most typical aspect of cross-site request forgery. But API authentication is usually not, or often not done via cookies, but rather via token. So server-side request forgery it's a thing. It is number 10 in the web OWASP top 10, but it did not come in based on data. It came in based on a survey which basically said, okay, dear practitioners, an audit is always a look into the past. Are there any things you think they might grow in importance in the future? If so, we could add this to the OWASP top 10 as well. And well, essentially server-side request forgery then got the number 10 spot, but wouldn't have gotten that based on the data alone. And here's on number 7, because maybe it's a bit more typical for APIs. we just talked about this effect that you have a URL and then your email client is calling that URL to display the picture or to check it, right? So you can trigger your email client potentially. Well, let's not use the email client. Let's use web-based email application. You can trigger the server that runs the email application to do an HTTP request, essentially, right? To check the link, whether the target of the link is malicious or contains, I don't know, uh, a virus. And server-side request forgery is basically that attack. So we, as the attacker, prompt a system, a server, to send an HTTP request to a third party. Now, is that a problem? I mean, does it make sense? Doesn't it make sense that, for instance, we check specific links in an email before displaying that email to the user? In theory, yes. But let me give you a totally hypothetical example. Let's just imagine we are using let's say whatever Outlook.com, right? And I'm sure there are safeguards in place, right? But let's just imagine. Okay, so Outlook.com is checking all links in emails before displaying it in the web browser, right? And so let's just imagine there is this super secret Azure God mode admin page, and the URL is godmode.azure.com. Well, I hope that doesn't exist. Anyway, but that's not publicly accessible, right? Because that's within the DMZ. You can't access it. But Outlook.com also runs on Azure, and Outlook.com happens to be in the same DMZ and therefore can access that God mode site, right? So we kind of make Outlook.com on the server send a request to that internal system, right? And you see, I mean, it took me like a minute to describe, at least a minute to describe this attack, right? The stars have to be aligned perfectly, right? I mean, finding a web application that I can trigger or prompt to send an HTTP request to a third-party site. I mean, that works, right? I mean, there are websites where you can enter URL and it checks the URL for, I don't know, for accessibility posture or something. So that works. But the secret, of course, is finding a system that I cannot directly access, right? But that service can access, and then finding an HTTP request that actually does some harm, right? So it could be a request that does something to the target server, but usually the requests I can trigger are GET requests, and GET requests shouldn't change the state of the application according to the REST principle. Or I can query data from the server that data is then returned to the server I'm attacking, and for some reason the server I've attacked is now returning the data to me in the browser as well, right? Stars have to be aligned perfectly. There are really nice proofs of concepts for server-side request forgery. But at least in my personal, but of course anecdotal experience in the audits I'm doing, I do find web applications that I can send an HTTP request to a target of my choosing. So I can show there's hypothetically server-side request forgery, but usually I cannot give them an exploit that not only shows the vulnerability, but also the negative consequences, right? So, but it's only on number 7, right? So I take this. I accept this.
This sounds like a very good principle, which is very hard to use if we do not make mistakes in other areas.
Yes.
As you mentioned, like it's not only about sending this request, but also doing something that like we are after, right?
Yes.
Not just breaking something, obviously, that's a bug on its own, but we as attackers probably would like to benefit from that. So that makes it even harder.
Yes, absolutely. All right, we are approaching, almost the end. Number 8 is something that is also part of the OWASP top 10, but I think that's on number 5, if I'm not mistaken, security misconfiguration. So anything related to security, to configuration that is security related. So you don't enforce HTTPS. You don't use if the API is consumed by a web browser client. You don't use security HTTP headers for your API. Your CORS policy is accept control, allow origin star, which kind of would allow everything. So kind of these things, everything that is part of configuration. Now I have to be honest. Um, I I would not consider myself like an administrator, so like running service is not my main area of expertise. So I always say, okay, someone else has to do that. But now with DevOps or DevSecOps or SecDevOps, I mean, I have to do that. Also, I mean, those security related headers, should the team running the server set them? No, of course not, because they have an effect to the application, right? So I, as the person doing the application, I should specifically set those headers. I mean, there are some configurations like don't send full stack traces to the client in case an exception occurs. Maybe this can be done on the server level, but yeah, many of those configuration aspects, they are also cookie flags, for instance. They are they are my responsibility, and therefore security misconfiguration. A bit surprised that it comes so late, but indeed, it is there.
Yeah, exactly. Exactly, especially that we as developers, we very often turn them off in local environments, right?
Yeah,
As you mentioned,
yeah,
like I course put it star just because I don't want to,
yeah.
waste my time configuring
Yeah,
that.
yeah. I
But
don't
the
even
other
know how
thing,
course is working, right? Let's just
yeah,
get this out
exactly.
of the way, right?
Yeah, but the other thing, even OWASP mentions for this rule, is the problem with Java and JNDI,
Yeah,
and that was the thing that, well, for .NET developers, that may be a little bit surprising, but
mm,
Java's logging
yeah,
libraries, they really allowed for crazy
yeah,
stuff, and there was this attack for using JNDI, which basically allowed us that if we log something, and how many times we just log the input that we get to our
yeah,
APIs, then because of fancy pattern replacement, that was basically doing a network call
yeah.
to some remote server. So our logging library could be doing very crazy stuff, and this is also included
Yeah, so that
in
was the
this
famous
rule.
log4net vulnerability, right?
I don't know whether it was in Log4net. It was definitely
Yeah,
in Java's
yeah. And that was
Log4j,
JNDI.
right?
Yeah, exactly,
Yeah,
exactly. I
yeah,
think
yeah.
that
So
definitely.
probably Log4net
Yeah,
could be,
yeah.
exploitable in very similar manner.
All right.
So generally, it's not only what we can do, but also
Yeah,
what our dependencies do, right? How
exactly,
many times we just
exactly.
take the logging
Yeah,
library, right?
yeah,
Cool.
exactly. All right. Number 9 is improper inventory management. Typical example: you have your API, but you also have a publicly available QA version of your API. And maybe that is running a different version or doesn't have the same level of protection. A story I'm always love to tell, and I can only tell because I think it's now almost 25 years ago. So I was working for a company that did web applications for rather well-known companies, and let's just say for ABC Corp, they did their main web application as well. And I mean, ABC Corp was like Fortune 500 company, and so they had a publicly available test server because back then, VPN and stuff like that was too complicated. I don't know, and that was abc.test. Name of the company I was working for.com. But of course, you can't just publicly access that. So there was HTTP basic auth, and the username was ABC, and the password was CBA. Now imagine what
Sounds very
happened
secure.
if I mean, no one knew this, right? But the company didn't just have ABC Corp as a customer, but also DEF Enterprises. Now, guess what the name of the test server was of for DEF Enterprises, and what the credentials were, right? And with improper inventory management, really, okay, which kind of versions of the APIs do you have? Just knowing what is out there, not that there's this old, maybe insecure version that has been deployed once to a server someone forgot, right? So just know uh, what your inventory is. Right? So that's it. Sounds simple, right? But especially when things are complex and you have different versions, etc., etc., then this is something um, that always should be taken into
I
account.
think one challenge here also, which is, let's say, a little bit more practical, is that when we run multi-tenant application, right, then it may be that we need to, for some tenants, we need to keep those older APIs. And if anyone finds vulnerability that is like even fixed in the newer version, and we put that in changelog or whatever, someone may look for older versions still running.
And now that you mentioned that, completely unrelated, but the vulnerable framework, I just remembered it was not log4j. So apologies for the team there. It was log4j. I'm pretty sure it was log4j.
Yep.
That had the vulnerability. Okay, sorry for that, but now it has been fixed, right? But was quite an outcry. All right.
And we believe no one runs the old version anymore.
Yeah. Let's hope for that. All right, and actually that brings that's actually is segueing over fantastically to the final entry of the OWASP API security top 10. Number 10 is unsafe consumption of APIs, because I mean I've all been talking about for many of the preceding items on the API top 10 is that don't trust user input, validate what you can, etc. But what if you are consuming other APIs as well? It's like having a dependency in your web application, having other APIs. Of course, the data, the information you get from other APIs, it's also something that should be validated and cannot automatically be trusted, right? Because that API might be overtaken by someone else. You don't control it, right? So you must not trust it. So don't just distrust, if that's a word, your users. Also, do not trust any other APIs you're calling, even if you call them internally, right?
And I think one thing worth mentioning here is that relying on RFCs or standards may also be super misleading, right? Because even if we follow RFCs, that does not necessarily mean others do the same. And so we may get like invalid input because of whatever input that we do not expect. And there we come to the rule of thumb you already mentioned, validate all.
Absolutely. So that were the 10 items of the OWASP API Security Top 10, again, from May 2023. And I'm all for awareness, so I can just recommend everyone check that out if you're working on APIs. And yeah, I just have to hammer that point home once more. Awareness is the key, right? You can't protect your web applications against something you don't know about.
That sounds cool. So thank you, Christian, for this this amazing piece of knowledge about OWASP. And Ping, let's actually move on to some picks for this week's episode. So I can begin.
Yes, sure.
To give you a little break. So my pick for this week is Servio. Servio.net is one example of various applications that do something that Christian may call insecure, which is exposing local applications publicly. I mean, how many times we had this case that, hey, I do run something which is exposed on localhost whatever, and I just need to access it from somewhere else, for instance, from my mobile phone for whatever reason, because I'm doing mobile development, right?
Yeah.
How do I do that easily? And obviously, I could take any VPS, expose SSH, and then do remote forwarding. But if we really need to do that for like a minute or very quick and dirty, then the application is doing that for us. So Servio is one of them. It works really nice, is pretty simple to use. Just keep in mind it may be a little bit dangerous. So when you go back home from your office, always steer the tunnel down.
Absolutely. That makes absolute sense.
What's your pick, Christian?
I'm doing a streaming pick. Just as an homage to our co-hosts that are not there yet. And I have to admit I'm late to the party, but that's maybe also because I'm more of a binging type. So for select shows, if it says, okay, every Friday, new episode, right? That's kind of nice. So, okay, I got a date on Friday, right? But sometimes it's like, oh, they always have cliffhangers in each and every episode. No, I'll just, binge a couple of them and, decide when I stop. And And so I may be late to the party here, but my pick is maybe somewhat surprising. It's Star Trek: Strange New Worlds. When I was growing up, I didn't really watch the original series, but I was watching Star Trek Next Generation, and I really loved that, right? That, every episode was more or less separate from the others. Yes, there were story arcs, but I really liked that chemistry of the cast, etc. And I found, I had some issues with Star Trek Discovery, also some parts of Star Trek Picard, except for the third season because they brought the Next Generation cast, right? So that was kind of like my youth again. Yeah, and with Discovery, I had issues with some of the characters, right? And so when I saw Star Trek: Strange New Worlds, I like, it's the same thing again. Yeah, let's watch something else. And then a friend, she kind of said, no, you have to watch that. Actually, it's now in the second season. I think it runs on Paramount Plus in most markets. So I started with season one because all the 10 episodes are already there. So I was watching this like in 3 nights or 4 or evenings. And it's like Star Trek Next Generation. Fantastic cast, working together so well. They do have story arcs, but still each episode is different. There are some shocking moments though, but great villains, great characters. Lot of fun. The only issue is now that I've watched season one, of course, I will watch season two, but season two is still, going on. I don't know. Is it like the fourth episode now as we're recording, something like that? So I have to wait for probably 2 more months until the series or the season has been completed, and then I just take off for 3 days and then I catch up.
That's always the risk of starting something that hasn't been completed yet. My case for that is like Patrick Rothfuss, The King
Hmm.
Killer.
Hmm.
Fantastic series, which was supposed to be a trilogy, and we are waiting for the third part for, I don't know, 15 years now.
Yeah.
Hopefully one day.
Fingers crossed.
So I
Fingers
know
crossed.
your feeling. Yeah.
Fantastic. All right, that's been a great episode. Thanks so much, Adam. Thanks
Thank you,
everyone listening in.
Christian.
And
And
I think
yeah,
we have a lighter schedule. I think during the summer, but we'll be back on track at least after summer. But still, we'll drop some episodes in between. And yeah, with that, thanks for
thank you,
me.
everyone. And let's tune in for the next episode of Adventures in .NET.
Thanks a lot. Bye, everyone.